You are about to do something no human being has ever done. You are about to stand on the surface of Europa, a small moon orbiting Jupiter, hundreds of millions of kilometers from home. As your spacecraft descends through the final few kilometers, you cannot stop staring out the window. Below you stretches a landscape unlike anything on Earth, a frozen shell of ice crisscrossed by thousands of dark, reddish lines that stretch from horizon to horizon. You're about to find out what it actually feels like to walk on one of the most fascinating moons in the solar system. Your landing craft touches down gently, and the engines power off. For a long moment, you simply sit there, listening to nothing at all. Europa has almost no atmosphere, so there is no wind, no weather, no sound carried through the air. When you finally step outside and your boots make contact with the ice, you feel something strange immediately. Your body feels lighter than it has ever felt before. Europa's gravity is only about 1/8 of Earth's, so a jump that would barely lift you off the ground at home now sends you several meters into the air. Scientists have confirmed this gravity value through decades of spacecraft tracking, so this is something you can rely on as solid fact. As you take your first careful steps, you notice the ground beneath you is not soft snow, but something closer to solid rock. The surface ice on Europa is extremely cold and extremely hard, with temperatures around negative 170 degrees Celsius at the equator and even colder near the poles. This is confirmed by infrared measurements taken by the Galileo spacecraft in the 1990s and more recent observations from the Hubble Space Telescope. At this temperature, ice behaves less like the ice in your freezer and more like solid stone, brittle and unforgiving if you fall. You look up and the sky takes your breath away. There is no blue atmosphere here to scatter sunlight, so the sky above you is pure black, even though the sun is shining. And dominating that black sky is Jupiter itself, an enormous banded giant covering a large section of your view, far bigger and more dramatic than the moon ever appears from Earth. This is not an exaggeration for effect. Because Europa orbits so close to Jupiter, the gas giant genuinely fills a significant portion of the sky, a detail confirmed through simple orbital geometry and decades of spacecraft imagery. But that's only the beginning of what makes this place extraordinary. As you walk further, you begin to examine those dark lines you saw from orbit. Up close, they are not simple cracks. They are long ridges and fractures, some stretching for thousands of kilometers, colored reddish-brown against the icy white surface. Scientists call these features lineae, and current evidence suggests they form when the ice shell flexes and cracks under the gravitational pull of Jupiter, allowing material from below to seep upward and stain the surface. The reddish color itself remains an active area of research. Current hypotheses suggest it may come from salts or sulfur compounds altered by intense radiation, though the exact chemistry is still being studied. This is something scientists are still working to confirm, not a settled fact. Speaking of radiation, you can feel its presence even without sensing it directly, because your spacesuit reminds you constantly through warning displays. Europa sits deep inside Jupiter's powerful magnetic field, which traps enormous amounts of charged particles and accelerates them toward the moon's surface. Spacecraft instruments have measured radiation levels here that would be lethal to an unprotected human within hours. This is why your mission depends entirely on heavy shielding, and why any future human visit to Europa would require either thick-walled habitats or surprisingly short surface excursions. This is confirmed scientific fact, measured directly by missions like Galileo and more recently Juno. You continue across the ice, and a thought crosses your mind that scientists have wondered about for decades. What lies beneath your feet? Europa's surface might look like a dead, frozen world, but the evidence tells a very different story. Measurements of Europa's magnetic field by the Galileo spacecraft showed a signature consistent with a global layer of salty liquid water hidden beneath the ice, possibly 40 kilometers deep in places, sealed beneath an icy shell that could be 10 to 25 kilometers thick. This conclusion is widely accepted among planetary scientists today, making it a strong current scientific hypothesis, even though no spacecraft has ever drilled through the ice to confirm it directly. Yet an even greater discovery awaits your attention, one that has captured the imagination of scientists worldwide. In 2012 and again in subsequent observations, telescopes detected what appeared to be plumes of water vapor erupting from Europa's southern regions, shooting up to 200 kilometers above the surface. If confirmed and consistent, these plumes would mean the ocean beneath your feet occasionally vents directly into space, offering an almost unbelievable opportunity. A spacecraft, or perhaps one day a human explorer, might be able to sample Europa's hidden ocean without ever needing to drill through the ice at all. It is important to note that these plume detections have been inconsistent across different observations. So while they remain a serious and exciting area of research, scientists classify their existence as a current hypothesis rather than a confirmed fact. As you stand there, looking out across this alien ice field with Jupiter looming silently overhead, you start to grasp the central question that brought you here. Why does any of this matter? The answer connects to one of the biggest questions in all of science. Are we alone in the universe? Europa's subsurface ocean is thought to contain more liquid water than all of Earth's oceans combined. Liquid water, a stable energy source, and the right chemical ingredients are the three basic requirements scientists look for when assessing whether an environment could support life. Europa may have all three. Tidal flexing caused by Jupiter's gravity continuously heats Europa's interior, possibly creating warm conditions on the ocean floor similar to hydrothermal vents on Earth, the very places where some scientists believe life on our own planet may have begun. This remains a hypothesis, but it is one taken seriously by major space agencies, which is precisely why missions have been designed to study it. You think about the practical challenges facing anyone who might want to live and work here long term. The radiation alone makes permanent surface habitation extremely difficult without heavy shielding. The cold would destroy unprotected equipment within minutes. Communication with Earth would take roughly 30 to 50 minutes round trip, depending on the positions of Earth and Jupiter, meaning no real-time conversation, only patient, delayed exchanges. Long-term survival here would likely depend on underground shelters built into the ice itself, using the frozen shell as natural radiation shielding, a future possibility supported by current engineering concepts rather than something humanity has built yet. As your time on the surface comes to an end, you take one final look around. The black sky, the silent ice, the towering presence of Jupiter overhead, and the knowledge that somewhere far beneath your boots, an entire ocean might be moving in darkness, untouched by sunlight for millions of years. NASA's Europa Clipper mission, launched in 2024, is now on its way to this very moon, designed to study its ice shell, its ocean, and those mysterious plumes in unprecedented detail. It will not land, but it will fly close enough to gather data that could finally answer many of the questions you've been grappling with on this imagined journey. What it finds may shape how humanity thinks about exploring this distant moon in person one day. Standing here, lighter than you've ever felt, beneath a sky dominated by a giant planet, on top of an ice shell that may hide an entire ocean, and possibly the conditions for life, you realize something simple but profound. We did not need to invent an alien world to find one this strange and this wondrous. Europa was here all along, hidden beneath the ice, waiting for the science to catch up. And in many ways, that is far more remarkable than any fiction could ever be.